Berlin, February 23, 1943. The heart of the Third Reich beats faintly beneath a blanket of ash and ruin. Allied bombs tear through the capital with mechanical precision, reducing once proud neighborhoods to endless fields of rubble. Amid the devastation, one building still stands, the headquarters of Telefunken, Germany's leading electronics firm, and the nerve center of the nation's radar research. Inside, behind blackout curtains and guarded corridors, a discovery is about to shake the foundations of Nazi science. Oberstleutnant Wilhelm Runge, a sharp, methodical engineer in his early 40s, sits alone at a cluttered laboratory bench. The room smells of solder and machine oil. Through cracked windows, faint streaks of red light flicker from distant fires. Before him lies a small copper block, recovered from the wreckage of a downed British bomber 3 weeks earlier near Rotterdam. German recovery teams had catalogued dozens of strange instruments from Allied aircraft before, new radios, proximity fuses, cryptic wiring, but this was different. It seemed almost deliberately sealed, as if guarding a secret. Runge adjusts his magnifying glass, the lens trembling slightly in his hand. The object is no larger than a teacup, perfectly machined from solid copper, with a cavity carved into its center and intricate ridges spiraling like frozen ripples of water. He scribbles in his notebook, "Precision astonishing. Beyond our machining tolerances. Function unknown." He unscrews a panel, peers inside, and then stops. The moment feels unreal. The markings, the structure, the design, they defy everything German scientists believed about radio engineering. He calls over his assistant. "Look at this," he murmurs, sliding the copper piece under the lamp. "It's not just a transmitter. It's something far more advanced." The assistant squints, unsure what he's seeing. Runge continues, his voice tightening with disbelief. "This device, it generates microwave frequencies, power at a wavelength we thought impossible." He's looking at the cavity magnetron, the beating heart of Britain's secret radar system. For years, Germany's radar development had lagged just behind the Allies. Their early warning systems, though competent, could never match the precision of British radar, especially at detecting aircraft at long range or at night. Now, as Runge studies this copper block, he realizes why. This single device, no larger than his hand, represents a technological leap of almost a decade. He jots down a line in his classified report, "This cannot be real. No nation could achieve such miniaturization while producing such power output." He leans back, silent, as the room hums with the faint sound of an electric transformer. Outside, the dull thud of distant bombs punctuates the night. But for Runge, the noise fades away. His thoughts are fixed on this small copper secret. If the British truly had mastered this technology, then every Luftwaffe radar station, every night fighter crew, every anti-aircraft battery was effectively blind. The cavity magnetron was a weapon of invisibility, the key to the Allies' growing dominance in the skies. While German scientists relied on cumbersome transmitters that operated at long wavelengths, the British had discovered how to harness microwaves, ultra-short radio waves capable of seeing through darkness and weather with unmatched clarity. With magnetrons, British bombers could navigate precisely. Their radar-guided systems could spot submarines, ships, and even land targets with eerie accuracy. And worst of all, the Germans had never known it existed. Runge carefully reassembles the device, his face pale. "We are behind," he whispers. "Years behind." At that very hour, hundreds of miles away in England, men and women of the TISARD mission and RAF scientists had already perfected radar sets powered by the same device Runge now holds in his hand. To them, it was a triumph of British ingenuity. To Runge, it is a revelation and a humiliation. By dawn, his report is on the desk of a Luftwaffe general. "A miniature microwave generator," the report begins. "Output energy beyond our theoretical limits. Likely source of superior Allied radar." The general reads it twice, frowning. He doesn't fully grasp the science, but he understands the implication. If the Allies could see what Germany could not, then the Reich's defensive wall was built on sand. Over the next days, the copper block, still referred to as the British device, is passed between laboratories like a sacred relic. Telefunken engineers, Physicists from the University of Göttingen and experts from Siemens all examine it. Each delivers the same verdict. It is beyond replication. The internal precision requires tools Germany does not possess, and the resonant frequencies it generates fall far outside known radar models. One scientist reportedly mutters, "It's as if the English stole technology from the future." By March, Runge's findings reach Albert Speer, Hitler's Minister of Armaments. Speer, alarmed, orders the Reich's top research units to close the gap immediately. But time, like copper, is unyielding. Germany's war machine is already stretched thin. Factories are bombed, materials are scarce, and the Allies, thanks to this invisible advantage, strike harder every month. Meanwhile, in England, the same magnetron technology is being mass-produced under top secrecy. Engineers at the H-2S radar program install them into bombers, allowing crews to identify cities through cloud and darkness. AF aircraft now fly confidently over Europe, guided not by stars, but by radio echoes. Each bomb that falls on Berlin carries not just explosives, but proof that the Allies have mastered the invisible war of frequencies. Back in Telefunken, Runge grows increasingly restless. He spends nights at his desk, red-eyed, surrounded by open notebooks and sketches. He tries to reverse engineer the magnetron, but its internal geometry defeats even the best German lathes. When he measures the frequency bands, his instruments can barely detect them. It is as if he's staring at a new form of energy. This device, he writes in frustration, is not just a transmitter, it's a revolution in physics. The irony isn't lost on him. Germany, once the birthplace of modern science, home to Einstein, Planck, and Hertz, now trails behind a nation it once dismissed as technically inferior. The copper secret, as his team privately calls it, becomes a symbol of a deeper truth. The war would not be won by armies alone, but by laboratories. As months pass, Telefunken's efforts to replicate the magnetron fail. Precision machining, vacuum sealing, and power control, every step requires resources they no longer have. Allied bombings cripple supply lines. Skilled workers are drafted to the front. The once mighty industrial engine of the Reich begins to stall, and the copper block, locked inside a lead-lined cabinet, becomes a silent reminder of what might have been. Runge continues to study it in secret. His notes grow darker, almost philosophical. "We are craftsmen working with candles while the enemy builds with lightning." He realizes that this discovery is more than a scientific curiosity. It is a mirror reflecting the Reich's technological decline. Every night, Allied bombers guided by radar cross the channel and find their marks. The Luftwaffe's defenses, unaware of the invisible beams sweeping across the sky, grow weaker with each passing raid. Berlin burns, and the copper block sits quietly in a drawer, its secret already shaping the outcome of the war. By the end of 1943, Runge's laboratory has been evacuated to avoid the bombings. His research vanishes into the chaos of collapsing bureaucracy. But the object, the British magnetron, survives, smuggled westward with other special devices. Years later, after Germany's surrender, Allied intelligence teams find it stored inside a crate labeled "Radar Components, Confidential." When British officers open the box, they recognize it instantly. One laughs softly, turning to an American colleague. They finally found it, a bit too late. The discovery of the cavity magnetron remains one of the most significant moments of technological revelation in the entire war. To the Allies, it was the invisible edge that made radar-guided bombing and navigation possible. To Germany, it was a symbol of a fatal lag, a realization that brute force and ideology could not compete with quiet precision and scientific collaboration. In the end, it wasn't tanks, nor planes, nor even armies that decided the skies over Europe. It was copper. It was science. It was the silent pulse of a frequency that no one could see, except those who knew how to listen. The copper block that trembled in Runge's hand that February morning represented more than a technological mystery. It marked the moment Germany realized it was fighting not just a war of nations, but a war of minds. And in that war, the invisible war of radio waves and frequencies, the Third Reich was already defeated. Night over the Netherlands. February 2nd, 1943. The rain falls in long silver streaks across a moonless sky. From the darkness above, the deep, rhythmic hum of 4 Merlin engines echoes faintly through the clouds. It's a short Stirling bomber, serial number R9264, one of Britain's newest long-range bombers. Its mission tonight, to strike the German industrial complex at Cologne and return to base before dawn. But this aircraft carries more than bombs. Hidden deep in its belly, behind armored panels and sealed compartments, is a secret device known only to a handful of scientists and officers. H-2S, the world's first ground-mapping radar. It is the pride of British ingenuity, a machine that lets navigators see the land below through cloud and darkness. Using radio waves, it paints the world in echoes, turning rivers, cities, and coastlines into ghostly images on a cathode screen. With it, the Royal Air Force can strike targets even in the dead of night. But tonight, fate has other plans. At 17,000 feet near the Dutch coast, a German night fighter lurks unseen. The Liechtenstein radar aboard its nose, primitive but deadly, locks onto the Stirling's echo. Moments later, tracer rounds streak upward, orange sparks in the dark. The Stirling jolts violently. One engine bursts into flames. Inside, the crew scramble. "Fire starboard engine!" the flight engineer shouts. The pilot, Flight Lieutenant Bill Howard, fights the controls, but the heavy bomber is losing altitude fast. They're over enemy territory, no chance to bail out undetected. The altimeter spins. 8,000 feet, 5,000, 3,000. At 2,000 feet, the wings shear away. In the cold February night, R9264 plunges toward the flooded fields south of Rotterdam. At 23:17 hours, the bomber hits the ground and explodes, scattering debris across a quarter-mile of farmland. The crew, 7 men, die instantly. For the Dutch villagers nearby, it's just another crash in a long war. But for the German occupation forces, the next morning brings an unexpected discovery. A German recovery unit arrives at dawn. The wreckage still smolders, the air thick with the stench of oil and burned aluminum. Among the twisted remains of the fuselage, a corporal notices something odd. A large copper cylinder half buried in the mud, still attached to shattered wires and metal plates. "Radar, Jarrett?" he mutters. "Radar equipment." He calls his superior. Within hours, the site is cordoned off. Dutch resistance members, watching from the trees, know immediately this isn't an ordinary crash. The Germans work quickly, methodically, retrieving every fragment of equipment, even digging into the mud with shovels. Word spreads quietly through the underground network. One of them, a young courier named Peter van der Meer, cycles 40 kilometers that night to deliver a message to British intelligence contacts in The Hague. A bomber with strange equipment has fallen near Rotterdam. Germans have taken everything. But by the time the message reaches London, it's too late. The Germans have found it. The strange device, the H-2S radar, is rushed under heavy guard to a Luftwaffe signals unit in Utrecht. There, officers confirm what their scientists have long suspected. The British are using a new type of radar, unlike anything in German service. Within 48 hours, General Wolfgang Martini, head of Luftwaffe Signals Intelligence, receives the report on his desk in Berlin. Martini, a calm, precise man with an engineer's mind, reads it twice. The details are astonishing. The unit recovered from the bomber emits ultra-high frequency waves, short, tight pulses far beyond the capabilities of any known German transmitter. Martini immediately recognizes the potential danger. If the British can map terrain with radar, their bombers no longer need moonlight or clear skies. They can find cities, even ships, in total darkness. He orders the wreckage transported to Telefunken headquarters under maximum secrecy. His message to his engineers is simple: examine it, understand it, replicate it if possible. Back in the Netherlands, the wreck site becomes a forbidden zone. Local farmers are ordered away. German engineers pick through the mud for every scrap of the radar. They recover the copper cavity, intact. They find a shattered cathode ray tube, fragments of wiring, even the mounting bolts. To the untrained eye, it looks like junk. To Martini, it is the single most important technological find of the war. In London, the Air Ministry receives the first report of the loss. The radio operator's last transmission was routine. The bomber had been returning from its mission without incident. When it failed to report in, it was listed as missing. Only days later, through coded resistance channels, does the truth emerge. The wreckage has been captured, and the Germans have retrieved the radar. Panic ripples through the top ranks of the RAF's bomber command. The H-2S system had been the cornerstone of Britain's secret technological edge, the invisible advantage that guided night raids over occupied Europe. Now it's in enemy hands. Meetings are held at Bentley Priory and TRE Malvern, the British Radar Research Centre. Some argue the device will be too complex for the Germans to copy. Others, more cautious, fear the worst. One scientist notes grimly, "They won't need to copy it, they'll learn how to counter it." He's right. Within months, German engineers at Telefunken, led by the same Oberstleutnant Wilhelm Runge, who later examines the copper cavity, begin dissecting the H-2S system. They are stunned by what they find. The radar operates at 10-centimeter wavelengths, unheard of in German radar design. It produces images so clear that cities appear as luminous outlines, rivers as dark ribbons, coastlines as distinct curves. It is powered by the tiny copper heart, the cavity magnetron, which generates enormous microwave energy from a device smaller than a coffee mug. As Runge's magnifying glass trembles over the copper block, he writes in his report, "No nation could achieve such miniaturization while simultaneously producing such power output." His words echo the shock first felt at the crash site, the moment when German science realized it was behind. But for the 7 men who died aboard Sterling R-9264, there are no honors, no headlines. Their mission's failure will remain classified for decades. They never knew that in their final moments, as their bomber fell through the night, they carried the most valuable secret of Britain's air war. The tragedy at Rotterdam becomes a turning point, a silent exchange of knowledge bought with blood. The British lose their technological edge. The Germans gain the blueprint for a new kind of warfare, the War of Invisible Waves. In Berlin, General Martini walks the corridors of the Air Ministry with a copy of Runge's preliminary report in his hand. The city around him trembles from nightly raids guided by the very device he's now studying. He cannot ignore the irony. Britain's radar is both the sword and the shield of modern war. And now, Germany finally knows how it works. But Martini is no fool. He understands that knowledge is only power if it can be acted upon. He knows that Germany's industrial capacity is faltering, that its factories are burning, and that even the most brilliant discovery may come too late. Still, he writes a message to his engineers: "Begin development immediately. We must match the British system." This is priority 1. The order sets in motion a desperate scientific race, one that will stretch from Berlin to Hamburg, from the laboratories of Telefunken to the research centers of Peenemünde. The Reich will pour resources into building its own version of H-2S called Berlin Gerät, hoping to reclaim the skies. But as the war grinds on, the irony deepens. The crash that gave Germany the secret of Allied radar will also accelerate the Allies' countermeasures. British scientists, realizing their system is compromised, rush to develop radar jammers and spoofing signals to blind German defenses. The invisible war of frequencies intensifies. In the fields outside Rotterdam, the wreck of R-9264 is long gone. The Germans removed every trace, leaving only a scar of blackened earth. But for those who witnessed it, the farmers, the resistance, the soldiers, it was more than a crash. It was the moment the war's hidden front shifted. The 7 airmen who perished that night never knew the true weight of what they carried. Their sacrifice would ripple through laboratories, command rooms, and battlefields for years to come. The copper block that would later sit under Runge's trembling magnifying glass began its journey here, in the mud, in the wreckage, in the rain-soaked fields of a small Dutch village. A tragedy, a secret revealed, a turning point. The crash at Rotterdam changed the course of the technological war, and perhaps the course of history itself. Late 1942. The North Atlantic is a graveyard of steel and salt. For 3 years, Admiral Dönitz's U-boat fleet has ruled these waters. The submarines of the Kriegsmarine, stealthy and relentless, have strangled Britain's lifelines, sending convoys to the bottom of the sea faster than they can be replaced. The U-boat captains call it the happy time, when Allied ships burn on the horizon and victory seems inevitable. But as winter descends, something changes. Reports begin to reach headquarters in Lorient and Wilhelmshaven. Short, confused messages from commanders at sea. Attacked without warning. Aircraft in darkness. No radar signal detected. One after another, transmissions end abruptly, the last words often drowned in static. In the grey dawns of the Atlantic, survivors are rare. Those who are rescued speak of the same nightmare. Allied planes appear out of nowhere, diving through fog and storm, dropping bombs with terrifying accuracy. It defies logic. The submarine's radar detectors, the prized METOX systems designed to pick up Allied radar, remain silent until it is too late. At first, Dönitz refuses to believe it. The METOX device has saved hundreds of U-boats from ambush. It can detect Allied radar transmissions long before aircraft come into visual range. If the METOX is silent, then the enemy should be blind too. Yet reality tells another story. One patrol after another disappears without trace. By January 1943, the statistics are undeniable. In a single month, U-boat losses have doubled. Merchant sinkings, once counted by the dozen, have fallen sharply. Convoys now cross the ocean with increasing success. Something unseen hunts the hunters. At his operations room, Dönitz studies the map of the Atlantic. Red pins mark lost submarines. Black ones mark attacks. The red spreads faster every week. Around him, staff officers whisper theories. Allied code-breaking, new detection gear, some kind of long-range aircraft. But none can explain how these planes strike with such precision in darkness and fog. He demands answers. Reports from the field grow more desperate. U-564, under Captain Reinhard Suren, barely escapes after a night attack that leaves its hull shattered. The aircraft came out of the clouds, he writes. No warning, no METOX signal, only the sound of engines seconds before bombs fell. U-502 vanishes days later. U-606, U-444, U-753, all lost. German scientists at Telefunken and the Navy Research Office begin an investigation. They test the METOX receiver and find it functions perfectly. The problem, they conclude, must lie elsewhere. But one physicist, after reviewing intercepted British broadcasts, suggests a chilling possibility. Perhaps, he says quietly, the enemy no longer uses the frequencies we can detect. That guess is correct. Across the Channel, the Royal Air Force has equipped its patrol aircraft with a revolutionary new radar, the 10-centimeter H-2S system, powered by the same cavity magnetron recovered from Sterling R-9264. The new radar operates on wavelengths too short for the German METOX to hear. To the U-boats below, it is as if the Allies have turned invisible. Night after night, Allied bombers and coastal command patrols scour the Atlantic using these new eyes of the unseen spectrum. They detect the faint outlines of submarines against the cold sea, striking before the crews even know they've been found. What had once been the U-boat's greatest weapon, the darkness, is now its doom. By February, U-boat morale collapses. Crews sail knowing that death may fall from the clouds without warning. Some captains refuse to surface at night, robbing their vessels of speed and power. Others begin to doubt their equipment. Rumors spread that the British have found a way to see through fog or that their planes are guided by supernatural means. Among the men, it becomes known simply as the invisible enemy. Dönitz, a pragmatic commander, does not believe in superstition. But he cannot ignore the evidence. He orders an immediate technical review of the METOX detectors. New models are rushed to sea, but nothing changes. The losses continue. In one grim report, Captain Jürgen Oesten writes, "The enemy sees us always. We see him never." The pattern is unmistakable. Convoys, once helpless under the U-boat wolfpacks, now move safely under radar-guided protection. Allied Liberators and Wellingtons sweep vast sectors of ocean, their screens glowing with the faint echoes of German submarines. The hunters have become the hunted. In Berlin, General Wolfgang Martini and his signals experts finally piece the puzzle together. The mysterious copper device recovered from the Rotterdam crash, the cavity magnetron, is producing these invisible frequencies. The British, it seems, have mastered a new generation of radar. Martini sends an urgent memo to the Navy. The enemy's radar operates beyond the detection range of the METOX system. New countermeasures are imperative, but Germany's industry is stretched thin. Factories are bombed, materials are scarce. Developing a counter-radar takes months the Reich no longer has. Meanwhile, in the Atlantic, the slaughter intensifies. In March 1943 alone, 41 U-boats are destroyed. Dönitz, once confident that his submarines would starve Britain into surrender, now faces catastrophe. The proud commander who once promised Hitler control of the seas watches his fleet vanish beneath the waves. He calls his staff together. "We are fighting an enemy we cannot see," he admits. "If we cannot detect his eyes, we are blind." But the truth is deeper than blindness. The U-boat war, built on secrecy, stealth, and surprise, is being undone by pure science. The invisible pulses of the British magnetron have redrawn the rules of naval warfare. What once depended on courage and cunning now turns on equations and frequencies. For the men aboard the U-boats, the change is felt in silence and fear. The endless Atlantic nights become nightmares of listening. Every distant hum might be a radar beam, every flicker of static a sign that death is near. There is no warning, no defense, no escape. One survivor from U-665 later recalls, "It was like being hunted by ghosts. You felt them before you saw them. Sometimes you never saw them at all." By spring 1943, Dönitz realizes the truth he cannot change. The invisible enemy is not magic, it is technology. A small copper block, recovered from a crash near Rotterdam, now stalks his fleet across thousands of miles of ocean. The balance of power has shifted. The hunters who once ruled the Atlantic now hide beneath it. The unseen radar waves, born from a secret buried in a bomber's wreckage, have turned the tide of war. Admiral Dönitz stands before his chart of the North Atlantic one final time that winter. The red pins of lost submarines mark a pattern across the sea, a constellation of defeat. He stares at it in silence, realizing that the age of invisible warfare has begun and that Germany has entered it unprepared. For the U-boat men, the ocean is no longer dark. It is illuminated by unseen eyes. The fog, once their ally, has betrayed them. Above the endless waves, the invisible enemy waits, patient, relentless, and unstoppable. And in the heart of Berlin, within the laboratories of Telefunken, scientists work through sleepless nights, desperately trying to understand the weapon that has already decided their fate. The age of invisibility has arrived, and it belongs to the other side. January 1943. Berlin shivers under a hard winter. The air smells of coal smoke and fear. In the offices of the Naval High Command, crisis meetings stretch deep into the night. Admiral Karl Dönitz sits at the head of a long oak table, his face drawn, his voice sharp. Reports from the Atlantic lie spread before him, page after page of losses. The numbers are catastrophic. U-boats are vanishing faster than they can be built. He looks around the room, engineers, physicists, admirals, intelligence officers, all summoned to explain the unexplainable. "Gentlemen," Dönitz says, "our submarines are being hunted. They report aircraft appearing from nothing, attacking through fog and night. The METOX receivers hear nothing." What is happening? A scientist from the Kriegsmarine Signals Bureau clears his throat. Perhaps the English have found a way to hide their radar signals. Or they've changed frequencies slightly beyond our detector's range. Dönitz leans forward. How far beyond? Not far. A few megahertz, perhaps. He shakes his head. Then why do our detectors remain completely silent? No one answers. The silence grows heavy. Another man, a physicist from the Naval Research Institute, finally speaks. It is impossible for them to use much shorter wavelengths. Our own laboratories have proven it cannot be done. The power loss is too great, the components too delicate. It's a theoretical dead end. Across the table, an officer from Luftwaffe signals intelligence interrupts. Yet our U-boats are being found. Something is guiding the enemy's aircraft with perfect accuracy. The physicist shrugs. Then perhaps it is not radar. Perhaps infrared or some new acoustic method. Maybe they detect the heat from the diesel engines or listen for propeller noise. Theories multiply. Some claim the British are using magnetic sensors that feel the pull of steel hulls beneath the waves. Others whisper of new weapons, invisible light, electrical fields, even witchcraft. Dönitz cuts them off. We are not children. I want facts, not fairy tales. But there are no facts, only fragments, rumors, and a growing sense of dread. In Paris, similar meetings take place inside the German Naval Communications Command. Technicians pore over intercepted British radio traffic, searching for patterns that might reveal the secret. None are found. A report arrives from Norway describing Allied aircraft attacking in total darkness, far beyond known radar range. The conclusion is grim: the enemy possesses an entirely new detection system. Back in Berlin, Dönitz summons experts from Telefunken, Siemens, and the Reich Post Ministry. The laboratories that once prided themselves as Europe's finest are now under pressure to explain what they cannot yet imagine. At Telefunken, Oberstleutnant Wilhelm Runge listens to the panic with quiet frustration. He already knows the answer. The copper cavity magnetron sitting on his desk proves it, but his findings remain buried in technical reports that few read and even fewer believe. During a meeting at the Air Ministry, Runge presents his observations. The device recovered from the British bomber in Rotterdam, he says evenly, generates microwave frequencies at a wavelength of 10 centimeters. It can be used for radar imaging with extreme precision. An older scientist frowns. 10 centimeters? Impossible. No transmitter can produce such power at that wavelength. The valves would melt. Runge slides a diagram across the table. Not valves, cavities. The power comes from resonance within these copper chambers. The design is brilliant. It works. The room murmurs. One physicist shakes his head. We have studied this for years. It cannot be stable. Such devices would burn themselves out. Runge replies quietly, and yet, gentlemen, it does not. Still, disbelief fills the room. The idea that Britain, long dismissed as technically inferior, could achieve something Germany declared impossible wounds their pride more deeply than any bomb. At that very moment, hundreds of miles away, Allied aircraft equipped with magnetron radar are already sweeping the Atlantic skies, finding U-boats hidden beneath waves and clouds. In Berlin, the men responsible for defending the Reich argue about theory. Dönitz grows impatient. I do not care what is theoretically possible, he snaps. I care what is happening. And what is happening is that our boats are dying. He orders immediate testing of all captured Allied equipment. He sends urgent cables to Paris, Lorient, and Norway. Recover all radar remnants from wreckage. Everything, no matter how small. Days later, a courier delivers a package from Holland to Telefunken, fragments of the same radar system Runge has been studying. It confirms his conclusions completely. The British are indeed operating at centimetric wavelengths. Still, the disbelief continues. The Reich's scientific establishment refuses to accept that their enemies have surpassed them. One report even suggests the H-2S system must be a trick, a decoy device intended to mislead us. Another claims the captured components are theoretical prototypes never meant for combat use. In Paris, a Luftwaffe officer writes in exasperation, "They mock what they do not understand." Meanwhile, Dönitz's situation grows desperate. Submarine losses climb with each passing week. The term wolfpack, once a symbol of fear, now becomes a symbol of futility. Every deployment brings new funerals. He meets personally with his technical advisors. We are being hunted by an enemy that sees through night and storm. If our scientists will not believe what is before their eyes, then we are finished. But in the world of German science, arrogance still outweighs urgency. Many senior researchers cling to the conviction that the British are bluffing, that any technological advantage must be temporary or exaggerated. The Reich, they insist, remains the center of scientific progress. In private, Runge records his frustration in his diary. "The problem is not ignorance," he writes, "but pride. They would rather lose the war than admit they were wrong." In early February, Dönitz sends a final appeal to the Ministry of Armaments. He demands that full resources be directed toward developing new radar detectors capable of sensing shorter wavelengths. The response he receives is bureaucratic and cold. Work is underway. Results expected in due course. In due course, while men die by the hundreds at sea. Inside Runge's laboratory, the copper block still rests under glass, glowing faintly in the lamplight. Around it, his engineers work silently, knowing they are holding the answer everyone seeks but no one wants to believe. They run tests, chart frequencies, and calculate power outputs beyond any German transmitter. Each new result confirms the same truth. The British have achieved what German science called impossible. By the end of February, the disbelief can no longer stand. Telefunken's final report to the Luftwaffe High Command is blunt. The enemy's radar operates in the centimeter band. Its source is a compact resonant cavity generator, highly efficient, unmatched by any known German technology. The truth is undeniable. But the months wasted in argument have cost the Reich dearly. The U-boat fleet is crippled, Allied bombers roam the skies unchallenged, and the balance of technological power has shifted irrevocably. Dönitz reads the report in silence. The arrogance of his scientists has given him no victory, only graves. Germany's belief in its own superiority has blinded it to the reality already shining from Runge's laboratory table. The war of minds, the war of science, has been lost before the generals ever knew it began. And in the cold halls of Telefunken, the copper secret continues to hum softly, its frequency mocking the empire that refused to listen. February 5th, 1943. The snow falls quietly over Berlin, muffling the distant thunder of Allied bombs. At Telefunken's heavily guarded research compound on Tempelhofer Ufer, a black military truck pulls through the gates. Inside, cradled in a padded wooden crate, lies one of the most important scientific prizes of the war, the cavity magnetron recovered from the crashed British bomber near Rotterdam. Armed sentries escort the crate into a basement laboratory sealed by iron doors. It is here, under the supervision of Oberstleutnant Wilhelm Runge, that Germany will finally come face to face with the secret that has been haunting its submarines and darkening its skies. Runge opens the crate himself. Beneath layers of straw and protective wrapping rests a small, unassuming copper block. Its surface is scarred and dented, but its design radiates precision, a masterpiece of miniature engineering. The room falls silent. Even the guards seem to sense its significance. Runge turns to the assembled scientists. "Gentlemen," he says, "this is what our enemy uses to see in the dark." He has handpicked the men in this room, physicists, engineers, and electronics specialists from Telefunken, Siemens, and the Luftwaffe's radar division. Together, they will form what history would later call the Rotterdam Working Group. Their task: to dissect, analyze, and understand the device that threatens to turn the tide of the war. The first examinations begin cautiously. Under bright lamps, they unscrew the magnetron's outer casing and examine its interior, a honeycomb of resonant cavities arranged with mathematical perfection. Fine filaments and silver-plated surfaces glint beneath the microscope. Dr. Otto Hakenberg, one of Telefunken's most respected physicists, leans closer. "It's not a valve," he murmurs. "It's something entirely different." Runge nods. "It generates microwave radiation on a wavelength of about 10 centimeters. But the power output, that's what we need to measure." For days, they run tests. Wires snake across benches, instruments hum, and the air fills with the metallic scent of ozone. They record data carefully, every pulse, every fluctuation. Then, late one evening, a young engineer named Klaus Werner calls out from behind a scope. "Sir, we've got a reading." Runge and Hakenberg rush over. The instruments confirm it: 3.3 gigahertz frequency, 9.1 centimeter wavelength, and over 40 kilowatts of power output. For a moment, no one speaks. The numbers seem impossible. German radar systems, built on meter-scale wavelengths, operate with a fraction of that energy. Hakenberg breaks the silence. 40 kilowatts from something the size of a teacup. Incredible Runge exhales slowly. Now we understand. They can focus radar beams into pencil-thin precision. They can detect a submarine periscope, even a single man moving on the ground. The revelation spreads through the lab like electricity. The implications are staggering. British aircraft equipped with this technology could see through darkness, fog, and storm with clarity the Germans cannot match. Their bombers could navigate cities with pinpoint accuracy. Their ships could detect U-boats before a single torpedo is fired. It's as if, Hakenberg says quietly, the enemy has artillery while we are still fighting with rifles. They dismantle every part of the magnetron, photographing and sketching each component. They trace the resonant cavities, measure the copper's purity, and analyze the magnetic fields. The craftsmanship leaves them humbled. The design is elegant yet brutally efficient, the work of minds far ahead of their time. Reports begin to flow from the working group to the Luftwaffe High Command, each report more urgent than the last. February 10th, 1943. Preliminary findings. The device is a cavity magnetron capable of generating microwave frequencies with extreme power density. No equivalent exists in German research in February 14th, 1943, technical evaluation. Such technology renders all known German radar systems obsolete. Countermeasures are urgently required. February 18th, 1943. Strategic implications. If deployed widely, this technology allows enemy aircraft to detect submarines and surface vessels, regardless of weather or visibility. Immediate research into centimetric detection is imperative. In one corner of the lab, Runge keeps a small notebook. In it, he records his private thoughts. We are witnessing a scientific revolution. Everything we believed about the limits of radar is gone. The English have surpassed us not by luck, but by daring to go where we said it was impossible. Yet outside the laboratory, disbelief still lingers. Many in the German scientific establishment refuse to accept that Britain could achieve such mastery. The reports from Telefunken are met with skepticism. Some call them exaggerated, others dismiss them entirely. But inside the Rotterdam working group, doubt has been replaced by awe. Each test, each measurement, confirms the same truth. The Allies possess a radar capability Germany cannot yet replicate. The scientists work around the clock. They attempt to reconstruct the magnetron using German materials and tools. They find the tolerances impossibly fine, the copper alloys difficult to reproduce. The magnetic fields must be balanced with microscopic precision. One engineer sighs in frustration, even our best machines cannot mill copper to this accuracy. By the third week of February, exhaustion hangs over the team. Yet the mood is no longer disbelief, it is resignation. They understand now that Germany is behind, and dangerously so. One evening, as the group gathers for their final analysis, Runge addresses them quietly. Gentlemen, we have confirmed what we feared. The British have achieved centimetric radar. Our ships, our U-boats, our cities, all are exposed. The enemy can see us, and we cannot see him. No one responds. The room is heavy with the weight of truth. Dr. Hakenberg finally speaks. Then we must build one of our own. Runge nods. We will try. But it will take time. Too much time. Outside Berlin's air raid sirens wail once again. The scientists pause, listening to the rising howl. Allied bombers are approaching, guided perhaps by the very technology they have just uncovered. In the flickering light of the laboratory, the magnetron lies disassembled across the workbench. The copper still warm from testing, the air thick with the realization that the war has already shifted beyond their control. The Rotterdam working group has found the truth at last. But by the time Germany understands what it is facing, it may already be too late. February 23rd, 1943. Telefunken headquarters, Berlin. Outside, the city lies wounded. Smoke drifts above rooftops, and the sound of distant sirens mixes with the crunch of boots on frozen streets. Inside the marble halls of Telefunken, the air is different. Tense, electric, and heavy with the weight of revelation. In a high-ceilinged conference room, an oak table stretches the length of the chamber. At its head sits Reichsmarschall Hermann Göring, his uniform immaculate, his expression already sour. To his right, Admiral Dönitz, commander of the U-boat fleet, his face drawn and pale from sleepless nights. Around them, a dozen generals, scientists, and intelligence officers, all summoned for what has been labeled a matter of utmost urgency. At the far end of the table stands Oberstleutnant Wilhelm Runge, the man at the center of it all. He adjusts his glasses, a stack of technical reports before him, and begins to speak. "Gentlemen," he says, his voice steady but low, 3 weeks ago, a British Sterling bomber crashed near Rotterdam. Among its wreckage was recovered a radar apparatus unlike anything we have seen. My team at Telefunken has analyzed it in detail. What we discovered changes everything. He nods to an assistant who dims the lights and switches on a projector. On the wall appears a magnified photograph, the copper cavity magnetron. This, Runge continues, is the heart of the device. A resonant cavity magnetron. It generates microwave radiation at a wavelength of 9.1 centimeters with a frequency of 3.3 gigahertz and a power output exceeding 40 kilowatts. A murmur ripples through the room. Some of the officers glance at one another, unsure what the numbers mean. Göring frowns impatiently. "Get to the point, Oberstleutnant. What does it do?" Runge looks directly at him. "It allows the enemy to see what we cannot. With this technology, their aircraft can detect submarines, ships, even the outlines of cities through cloud, darkness, or fog. The British have achieved centimetric radar, something we believed impossible." The room falls silent. Dönitz leans forward, his voice tight. "You're telling me their aircraft can locate my U-boats, even when our METOX detectors hear nothing?" "Yes, Admiral," Runge replies. "The METOX was designed to detect meter-band emissions, around 1.5 meters wavelength. The British have moved to 9 centimeters. Your receivers are blind." The words hang in the air like a death sentence. Göring slams his fist on the table. "Nonsense! Our scientists would have told us if such power was possible. You're saying a British engineer, an Englishman, has outperformed the Reich's best minds?" Runge does not flinch. "I am saying precisely that, Herr Reichsmarschall." For a moment, no one breathes. Göring's face reddens, his pride wounded deeper than any bomb could strike. "Impossible," he mutters. "The English copy, they do not create." They do not lead. Runge slides a sheet of paper toward him. Test results, voltage readings, frequency graphs. "With respect, sir, these are not copies." "These are facts." Dönitz studies the graphs silently. His hand trembles slightly as he speaks. "How long until we can build one ourselves?" Runge hesitates. "Months, perhaps years. We lack the manufacturing precision and the specialized materials. Even if we succeed, deploying it across our fleet would take far longer." Dönitz closes his eyes. Then the Battle of the Atlantic is already lost. Across the table, a Luftwaffe officer shifts uncomfortably. "Surely we can develop countermeasures?" "A new detector, perhaps." Runge cuts him off. "We are working on it, but no detector currently exists that can sense such short wavelengths. Even if one could be made, it will not be soon enough." The room darkens further as clouds pass over Berlin. In that shadowed silence, the reality becomes clear. Germany, once the leader in military science, has fallen behind, catastrophically so. Göring turns on the scientists in the room. "How could this happen? We poured millions into radar research. Where were you all while the English built this?" One of the Telefunken physicists speaks softly. "We believed the theory unsound. We dismissed the possibility of high-power generation at such short wavelengths." "Believed?" Göring snaps. "You believed. Belief is for priests, not scientists." Runge's calm voice interrupts the shouting. "It is not a matter of belief anymore, Herr Reichsmarschall. It is a matter of proof. The device exists. It works. And it has already changed the war." Dönitz rises slowly, the weight of command pressing on him like lead. "You understand what this means for my men. They sail blind into a sky that can see them. Every convoy they approach, Every surface they break, they are watched. The ocean is no longer our shield. He turns to Göring. While you argue about pride, my submariners drown. For once, Göring has no reply. Runge closes his folder. Gentlemen, this discovery means that Britain now possesses radar superiority on every front: air, sea, and soon land. Unless we develop equivalent systems or effective countermeasures, our defenses will continue to fail. He pauses. The magnetron is small, yes, but it carries the weight of empires. The meeting ends in silence. One by one, the officers file out, leaving only Runge and his assistant in the empty room. Outside, Berlin's air raid sirens begin to rise again, a mournful, wavering howl. Runge steps to the window. Above the horizon, faint dots appear, Allied bombers approaching their spring 1943. The Atlantic Ocean, cold, endless, and unforgiving. Once, it had been Germany's hunting ground, the graveyard of Allied convoys. Now, it has become something else, a killing field, not for merchantmen, but for the hunters themselves. Above the grey horizon, British patrol aircraft carve lazy arcs through the mist, Sunderlands, Wellingtons, and Liberators. Beneath their bellies hums a new secret, the ASV Mark III radar, powered by the same copper heart that Runge's team uncovered months earlier. A radar so precise, it can detect the faint curve of a submarine's periscope, even in moonless darkness, even through storm and fog. Below the waves, the U-boats stalk as they always have. But something has changed. Aboard U-333, Kapitänleutnant Peter Erich Kremer stares at his instruments. The night is calm. The METOX detector hums softly, scanning the air for enemy radar signals, and finds nothing. Yet somewhere above, unseen, a Liberator already circles. The operator in its belly watches a glowing green screen as a bright dot pulses rhythmically, the echo of a steel hull slicing through the Atlantic. Target confirmed, the British officer says. Range 6 miles. Prepare depth charges. Minutes later, the sea erupts. Explosions churn the water, the lights flicker, alarms wail. Kremer shouts orders, diving deeper, twisting through the abyss. But it's hopeless. The enemy knows exactly where he is. By dawn, U-333 is gone, another mark in a long and growing list. In the first months of 1943 alone, more than 100 German submarines vanished beneath the waves. For the first time since the war began, Admiral Dönitz faces a truth he cannot outmaneuver. The Atlantic belongs to the Allies. From his command center at Carnival, near Lorient, Dönitz watches the reports pile in. Red pins cover the map: lost boats, lost crews, lost faith. He reads the radio logs. Attacked at night by aircraft, no radar warning. Depth charges precise, no chance of escape. Crew lost. Position unknown. He lowers his head. They are killing us faster than we can replace them. The magnetron, a copper device smaller than a man's fist, has done what thousands of Allied warships never could. It has robbed Germany of the deep. Across the Reich, panic seeps through scientific circles. Laboratories at Telefunken, Siemens, and Gema race to develop countermeasures. Engineers work without sleep, attempting to build detectors sensitive enough to pick up centimetric waves. The result, the Naxos system, appears months later, but by then, the damage is irreversible. In the North Atlantic, the numbers tell the story. Between March and May of 1943, the German Navy loses nearly 40% of its operational U-boats. Convoy after convoy crosses the ocean untouched. The hunters have become the hunted. One British airman later describes it simply. Before the magnetron, we hunted shadows. After it, we hunted ghosts and found them. In Berlin, Dönitz pleads for reinforcements, for answers, for hope. We can no longer fight the ocean, he admits to his staff. It belongs to them now. His voice breaks as he reads the latest casualty figures. Thousands of men, the best of Germany's sailors, lost not to superior ships or weapons, but to an enemy they never saw. The technological revolution that began in secret British laboratories now echoes through every corner of the war. What began as an experiment in microwave physics has become a weapon more deadly than any torpedo, and all of it, all the wreckage, the fire, the death, traces back to a single moment, a single discovery, a small copper block pulled from the wreckage of a bomber in a Dutch field. For Runge, the revelation is both triumph and tragedy. His reports, once dismissed, have become prophecy. He knows now what few will ever understand, that the war was not lost in the factories of Krupp or the bunkers of Lorient, but in the laboratories where pride blinded reason. He writes in his diary, "The ocean was not taken from us by force. It was taken by knowledge. The English saw what we could not, because they dared to look beyond the visible. By summer, the U-boat campaign, once the pride of the Reich, collapses entirely." Dönitz orders his submarines to retreat from the North Atlantic. The wolves return to their dens, broken and silent. The Battle of the Atlantic is over. The sea, once ruled by steel, now belongs to invisible waves. In the quiet that follows, Allied convoys move freely, carrying food, troops, and ammunition to Europe's western shores. The future invasion of the continent, D-Day, becomes possible only because of what the magnetron made visible. Back in Berlin, Runge's copper block still sits under glass, glowing faintly under a lamp. Around it lie the shattered illusions of a nation that believed it could conquer the world, and forgot that the greatest weapons are not forged in iron, but in thought. The invisible frequencies that hum between atoms and air have done what no fleet or army could. They have defeated a steel empire. And as the Atlantic waves roll endlessly toward the western shore, they carry with them the silent truth of modern war, that power no longer belongs to those who build the biggest machines, but to those who see the smallest things.